Trigonometric ratios. There are 6 trigonometric ratios and we will be studying them in a right angle triangle ABC, which is right angled at B, and we will be studying these ratios with respect to angle A. So, with respect to angle A, AB is the base, BC is the perpendicular, and AC is the hypotenuse. The first ratio is sin A. Sin A is basically perpendicular upon the hypotenuse, which is BC upon AC. Next is cosine A. Cosine A is base upon hypotenuse, which is AB upon AC. So it means sin A is perpendicular upon the hypotenuse, whereas cosine A is base upon the hypotenuse. Next ratio is tan A. Tan A is basically perpendicular upon the base, that is BC upon AB. BC upon AB. Tan A can also be written as sin A upon cosine A. That is the ratio of these two ratios is the tan A. Next is cot A. Cot A is base upon the perpendicular, that is AB upon BC. Also, it is the reciprocal of tan A, which gives us AB upon BC. Cot A can also be written as cos A upon sin A. Next is secant A. Secant A is the reciprocal of cosine A, which leaves us with hypotenuse upon base, that is hypotenuse upon the base, which leaves us with AC upon AB. The last ratio is cosecant A. Cosecant A is the reciprocal of sin A, which leaves us with hypotenuse upon the perpendicular, which gives us AC upon BC. Now, the important thing is tan A can be written in form of sin A and cosine A, their ratio, and it can also be written in terms of cosecant A and secant A. That gives us with secant A upon cosecant A. Same is with cot A. Cot A can be written in form of cos and sin, and it can be written in terms of cosecant and secant also. So let us do the first question. The first question is, if sin A is equal to 3 by 5, find all other ratios. There are total 6 ratios. We have been given the one ratio and we need to find the other 5 ratios. Okay. So let us say that ABC is a right angle triangle, right angled at B, and angle A is the one with which we have to find the ratios. Sin A is 3 by 5. Now, as we all know, sin A is perpendicular upon hypotenuse. Okay. So we can say that perpendicular, by comparing these two, we can say the perpendicular is 3 units and hypotenuse is 5 units. Now, we can apply the Pythagoras theorem in this right angle triangle ABC. Pythagoras theorem says that hypotenuse square is equal to perpendicular square plus base square. Now, we can rearrange this and we can say base square is equal to hypotenuse square minus perpendicular square, which gives us with 5 square minus 3 square, and solving this we get the value of base is 4 units. Now we have all the 3 things. We have perpendicular 3 units, hypotenuse 5 units, and we have found out the base, that is 4 units. Now cosine A is base upon the hypotenuse. Base is 4 and hypotenuse is 5, so the ratio comes out to be 4 by 5. Now tan A is perpendicular upon the base. Perpendicular is 3 and base is 4. So the ratio comes out to be 3 by 4. Cot A base upon perpendicular or the reciprocal of tan A. So it can be 4 by 3. Secant A is the reciprocal of cosine A, which is hypotenuse upon base, and it can be written as 5 by 4. Cosecant A is the reciprocal of sin A, that is given, sin A is given us as 3 by 5. So the reciprocal of this is 5 by 3. Now, there is one more question. If secant A is equal to 13 by 12, find all other ratios. This you can try it by yourself. It helps to practice. And there is one more question. Sin A is equal to 12 by 13. We have to find other ratios. In these both the questions, you can see that secant A is equal to hypotenuse upon base. So we have the hypotenuse, we have the base. We can find the perpendicular with the help of Pythagoras theorem, and then we can find all other trigonometric ratios. Similarly, this is the question. There is one more question. 15 cot A is equal to 8. So 15 cot A is equal to 8 means cot A is equal to 8 by 15. So we can say that cot A base upon perpendicular. Base is 8 units, perpendicular is 15 units. We can find out the hypotenuse and then we can solve this question also. Now let us do the next question. Cot theta is equal to 7 by 8 and we need to evaluate this value, that is 1 plus sin theta into 1 minus sin theta upon 1 plus cos theta into 1 minus cos theta. Now cot theta is given 7 by 8. We know that cot theta is equal to base upon perpendicular. So we can say that base is 7 units, perpendicular is 8 units. Now hypotenuse we need to find out. By Pythagoras theorem, we can say that hypotenuse square is equal to base square plus perpendicular square. So it gives us 7 square plus 8 square, that is 113. Adding, we get 113. Now hypotenuse is root 113 units. Now 113 is not a perfect square, so we cannot take it out of the square root. Let's solve like this only. Sin theta is perpendicular upon hypotenuse, which gives us 8 upon root 113, and cos theta is base upon hypotenuse, which gives us 7 by root 113. So 1 plus sin theta into 1 minus sin theta, that is the numerator. Okay, so we can say this is the famous equation. A plus b into a minus b is equal to a square minus b square. So this can be reduced to, if we take a as 1 and b as sin theta, into 1 minus sin square theta, which leaves us to 1 minus 8 by root 113 square is equal to 49 by 113. And similarly, we can do the denominator, that is 1 plus cos theta into 1 minus cos theta. 1 gives us 1 minus cos square theta. Putting the values and solving, we get its value as 64 by 113. So putting numerator and denominator together, we can say it that 49 by 113 divided by 64 by 113. Cancelling and solving this equation, we get 49 by 64, which is the value of the expression given. This was the expression that we need to find out, and this is the value that we find out. Now let us do the next question. The next question is, if 3 cot A is equal to 4, we need to prove that 1 minus tan square A upon 1 plus tan square A is equal to cos square A minus sin square A. So what can we do? We have cot A, we can find tan A, we can find cosine A, we can find sin A, and we can put these value in this expression to see if they are equal or not. So let us say that 3 cot A is equal to 4. Cot A is equal to 4 by 3, which gives us base upon perpendicular. Base 4 units, perpendicular 3 units. Pythagoras theorem, same. Hypotenuse square is equal to base square plus perpendicular square, which gives us hypotenuse as 5 units. Now, we need sin A, perpendicular upon hypotenuse 3 by 5. Cosine A, base upon hypotenuse 4 by 5. Tan A, base upon perpendicular upon base, 3 by 4. So left hand side is 1 minus tan square A upon 1 plus tan square A, which leaves us 1 minus 3 by 4 square upon 1 plus 3 by 4 square. So solving this, we get 7 by 25. Now right hand side we have cos square A minus sin square A. We have find out the values, so we can directly put in and solve this. Solving this, we get 7 by 25, which is the same as the value that we get by solving the left hand side. So right hand side is equal to left hand side, hence proved. Means this equation is valid. This is the equation that we need to prove, and this is valid. We get both the values as 7 by 25. Now the next question. In a right angle triangle, right angled at B, if tan A is equal to 1, then verify that 2 cosine A into sine A is equal to 1. Okay, so tan A we have been given 1. Tan A is basically perpendicular upon base, that is given 1, which means perpendicular is equal to base. So by Pythagoras theorem, we can say that hypotenuse square is equal to perpendicular square plus base square. So hypotenuse square is equal to perpendicular square plus perpendicular square. Since these both are equal from above, we can replace the base by perpendicular. And by solving this, we get hypotenuse is equal to root 2 into perpendicular, which is also equal to root 2 into base. Since these both are equal, we can directly put it. So now we need to find the sine A. Sine A is equal to perpendicular upon hypotenuse, perpendicular P. Hypotenuse, we have taken out the value root 2p. Putting this, we get the value of sine A as 1 by root 2. Similarly, cosine A, base upon hypotenuse, we can say base upon, this is the value of the hypotenuse in terms of base. So we can solve it and say that the cosine A values comes out to be 1 by root 2. Now, we need to prove that 2 cos A into sine A is equal to 1. Left hand side, let's put the value in the left hand side first. That is 2 into cosine A into sine A. So both the values are same, that is 1 by root 2. Putting this and solving, we get is equal to 1, which is equal to the right hand side that we need to prove. So it is hence proved. Now the next question. In triangle OPQ, right angled at P, OP is 7 centimeters, OQ minus PQ is 1 centimeter. Determine the value of sin Q and cos Q. So this is a triangle in which we can say that this is 7 centimeters and the difference is the value of this side and this side is 1 centimeter. We need to find sin Q and cosine Q. So these are the two things that we have been given in the question. So if we apply the Pythagoras theorem, hypotenuse square is equal to base plus perpendicular square, we can say that OQ square is equal to OP square plus PQ square. So putting in the value of OP, that is 7 centimeters, we know, and rearranging this equation, we can get this OQ square minus PQ square is equal to 49, and putting the value of A as OQ and PQ as B, we can apply this equation. A square minus B square is equal to A plus B into A minus B. So applying this, we get this equation, and in the question we have that difference between OQ and PQ is 1, which is given in the question, and OQ plus PQ we don't know. So by putting the value 1 in place of OQ minus PQ, we get the value of that OQ plus PQ is equal to 49. This is also the equation that we come. Now we can solve these two equations. OQ plus PQ is equal to 49 and OQ minus PQ is equal to 1. Solving these two equations, we have two variables. So we can simply add these two equations. Adding these two equations, we are left with that the value of OQ comes out to be 25. Also, now we can put the value of OQ in any of the two equations above and we get the value of PQ to be 24. So, PQ 24 centimeters. This is the base with respect to angle Q. Since we need to find cos Q and sin Q with respect to angle Q, this is the base, this is the perpendicular and this is the hypotenuse. So, sin Q is perpendicular upon hypotenuse, which is OP upon OQ. OP is 7 centimeters, OQ is 25 centimeters. So we can say that the value of sin Q is 7 by 25. Similarly, cosine q is base upon the hypotenuse. Base we have as PQ, whose value is 24. Hypotenuse is OQ, value of which is 25. So we get the cosine q is 24 by 25. So these are the two ratios that we need to find out, and we have the answer here. Okay. Next question is, can sine theta equal to 4 by 3 be possible? Okay. So sine theta is basically 4 by 3. We have to say that is it possible or not. Sine theta is equal to perpendicular upon hypotenuse. We all know that hypotenuse is the largest side of a right angle triangle, and perpendicular should be smaller than the hypotenuse, but the above ratio says that perpendicular is larger than the hypotenuse, which is not possible. So the value of sine theta as 4 by 3 is not possible. Next question is, if angle B and angle Q are acute angles such that sine B is equal to sine Q, then prove that angle B is equal to angle Q. This you should try it yourself. It will be very helpful. So this ends the part 2. Thank you. I'll be uploading the part 3 soon.